Hello everyone, in this video we're going to be solving a geometry puzzle. If you like this video, please comment, like and subscribe, and don't forget to hit the bell button for notifications. And let's get started. Now, we do have 3/4 circles that intersect inside a unit square, which means the side length is 1. Forming the regions shown, find the area of the region labeled A. So we do have that little weird shape, kind of like a triangle, but the sides are round, not straight. We're going to find the area of that region. So how do we go about that? Well, as always, we're going to make some connections. And let me just tell you at the beginning, there's more than one way to solve this problem, obviously, right? This is a very well-known figure, somewhat, I would say. But notice that I only drew 3/4 circles, not the fourth one. If you do the fourth one, you're going to get a bumpy shape in the middle, kind of like a pillow shape, and then you can use more symmetry. But we still have some symmetry, and symmetry is beautiful, don't you think? Yes? Okay, great, awesome. So I'm going to start by making a diagonal here. So I'm going to start here and end here. Beautiful. So that's basically going to cut the shape into two pieces, and from symmetry we can tell that this is going to be half of A and this is also going to be half of A, right? I think symmetry is beautiful. You know, we could probably write a book on symmetry. Okay, now what is the next thing? Well, I do need to make one more connection, which is super important. You might be calling this region B or something else, but I'm going to make one more connection, which is important. Okay, I'm going to start here at the center again, but I'm going to end up somewhere else this time. Cool. And I'm going to call these B and C, okay? Those areas, in other words. The area of each region is labeled by a capital letter here. Okay, cool. So you can go ahead and, calculate B, C, or whatever you want to do here. But anyways, I'm just going to follow a certain path here. So what is that? What does that involve? Well, I'm going to find C first. And then using C, I'm going to try to find B. Or I'm going to find B separately, probably. Let me think about it. Yeah, I can find B and I can find C separately. But here's a couple of things we need to think about. Okay, we're using a lot of good geometry here, by the way. This problem is really cool because this uses a lot of good geometry. Anyways, so how do you find C? Let's start with C. Well, C is kind of like a slice, right? Isn't that like a fraction of a circle? Yep. So the question is, what fraction of the circle do we have? And that can be found by using basic geometry. What is that one? Well, this is a 45-degree angle. Because this is a square, we're drawing diagonal, so on and so forth, as you know. And we are getting, actually, if you also make the other connection, which I'm not going to make, but I could probably make it, maybe use a dotted line. How about that? Let me use a dotted line. I think I can do that. Let's use a dotted line to indicate that because I think it kind of helps you understand the symmetry here. Here we go. Okay, cool. Now, consider this equilateral triangle whose side length is 1, right? So that tells you that, well, this is 60 degrees. Well, didn't turn out real well, right? Okay, so let's go ahead and turn to our normal pen. Okay, cool. So this should be 60 degrees, right? Therefore, the base angle for the equilateral triangle is also going to be 60. This is also going to be 60. We don't need to label that. But that gives you important information. It tells you that this is 15 degrees. Why? 60 minus 45 is equal to 15, right? Okay, cool. Now, how does that help me? Well, it helps me to find C. Because remember, C is kind of like a slice. Okay, you can think of the slice of a pizza maybe. And you only get 15 degrees. So what fraction of the circle do I have? Well, it's 1/6 of a quarter. So that would be 1/24th, right? So C is basically 1/24th of the full circle whose radius is 1. And the area of a circle is pi r squared. R is 1, so it's pi divided by 24. Beautiful. So we were able to find C. Let's go ahead and find B now. How am I going to find B? Well, to find B, this is what we're going to do. So we do have this weird triangular looking shape, but it's two of the sides are round, right? But notice that we do have this equilateral here in the middle, right? So basically, if you're trying to find C, you can consider this 60-degree slice and then subtract, if you're trying to find B, find the area of that little sector, which is 60 degrees, and then subtract the equilateral from it. That's it. So that's how we can basically find the value of B. I hope that makes sense. Or you can just go ahead and add the B twice to C, but then it's going to give you that weird shape again. Okay? I think it has a name, but I can't remember what it was. Okay, something like Penrose triangle maybe? Okay, anyways, whatever. It's called something. So what are we going to do next? So we're going to find the area of the slice, which means we're going to include this part as well, the B. So that's going to give me a 60-degree slice, which means that's 1/6 of a circle, correct? Okay, so, and then from that, I'm going to subtract the area of the equilateral. How do you find the area of the equilateral triangle? Well, the side length is 1. As you know, the area of an equilateral triangle is a squared root 3 over 4, right? When a is 1, then area is going to be root 3 over 4. Okay, cool. So that's the area of the equilateral triangle. Nice. Now, we need to subtract that from the 60-degree slice. Okay, so b can be found by then pi over 6, because 60 degrees is 1/6 of 360. And then from that, I'm supposed to subtract root 3 over 4, and that gives me b, which is this piece here. Okay, cool. So I was able to find c, I was able to find b, I should be able to find a or a over 2, but here's how you put it all together. If you add those pieces, so now we found b and c, so I can probably just go ahead and do some cleaning here. Okay, so do some cleaning so that we start off with a nicer shape. So I'm going to cut this in half again. Okay, this is my midpoint, and then this is my other connection, right? Okay, cool. Now, what did we say? We said that C is this little 15-degree slice here, right? Which we found by pi over 24, and B is this piece. So how do you put it all together? Well, if you consider the sum of B, C, and A over 2, you're going to find something interesting, right? You're going to find this bumpy shape. Let me shade this part so that we don't get confused. But this part is basically going to give you what? B plus C plus A over 2. But how do you find that piece? There's two of them, and they actually make a football shape, don't they? Yeah, okay. But here's the point. If you consider the quarter circle, the big one, and from that quarter circle, if you subtract, let me use a different color to shade that maybe. If you subtract this isosceles right triangle from the quarter circle, you're going to find that bumpy shape, right? Okay, cool. Let's do that. So in other words, B plus C plus A over 2 is going to equal what? The area of the quarter circle, which is pi over 4, right? Minus the area of the 45, 45, 90 triangle, which is 1 times 1 divided by 2, which is 1/2. Easy, right? Okay, cool. So now we're going to put it all together, and then we're going to simplify, and we'll get the answer. Okay, we're almost done. Now, how do we put it all together? Well, our goal is to find A, and we do know of B and C, so we can just go ahead and substitute. Let's go ahead and substitute everything here. I have it. Don't worry about simplifying or making a common denominator, because I'm going to simplify it all at once. So it's going to be pi over 6 minus root 3 over 4. That's B. Plus C, which is pi over 24, right? Plus A over 2. Don't forget, this is half of A only, not A, because we didn't use the whole thing because it wouldn't make much sense. You could double everything, but it's no big deal. So this should equal pi over 4 minus 1/2. Now, this expression might seem a little like too much work with fractions, but I'm going to eliminate that problem by using one of our common tricks that pretty much all the time. Multiply both sides by the least common denominator, which is 24 in this case. So I'm going to multiply both sides by 24 on the right-hand side and on the left-hand side, and let's see where this takes us. Okay. Of course, remember to cross-cancel. For example, 6 goes into 24 4 times, so that's going to give you 4 pi. 4 goes into 24 6 times, so this is 6 root 3. This should be a pi, and this should be 12a. All right? On the right-hand side, we have the 6 pi minus 12. Awesome. So I can go ahead and add these. 4 pi plus pi is 5 pi. If you subtract, so I'd like to leave the 12a alone on the left-hand side, so that what I can do is I can leave the a alone here, and then subtract 5 pi from 6 pi, which leaves us with pi only. And then everything else, add or subtract, whatever. So I've taken care of these, and then if I can add this to both sides, that's going to give me pi plus 6 root 3. And then minus 12 is already there, right? So I can leave it there. everything looks good now. So I have the 12 pi, I've taken care of these and everything else. Cool. Now, what am I going to do next? My goal is to find a, remember? So I'd like to divide both sides by 12. Make sense? Okay, cool. So a is going to equal then pi plus 6 root 3 minus 12 all over 12. Now, obviously, you can go ahead and simplify this fraction, or you can separate them like, you know, pi over 12 plus root 3 over 2 minus 1. Doesn't matter how you write it. At the end, it's the same answer. It's totally up to you if you want to simplify that. But this brings us to the end of this video. And thank you for watching. I hope you enjoyed it. I'll see you with another video tomorrow at the same time. Until then, I'd like you to be safe and take care. Bye-bye.